In this experiment, we're going to take some steel wool and we're going to burn it. To do that, I'm going to firstly weigh the steel wool before and after the burning. I have these sensitive electronic scales. They weigh to 4 decimal places. To begin with, we'll put our heat-proof dish and re-zero our scales. So you can see they're very sensitive and it's hard for them to get a complete zero because of just even fluctuations in the air. So we'll ignore that last decimal place, that's our room for error. If we place our steel wool on the crucible though, we get a reading here of 0.953 grams. So that's the weight that we'll take, not quite 1 gram of steel wool. We take our heat-proof dish out of there, we'll place it onto our heat-proof mat, and then we're going to burn that steel wool. Just position my camera over here so I have both hands free. To be thinking here, what are the signs of a chemical reaction? So burning the steel wool thoroughly. Just going to turn it over to make sure that the underside is also fully burnt. And when you see that it's no longer able to keep that alight, the material is fully burnt. Now we're going to re-weigh the burnt steel wool, taking our crucible, testing it's not too hot, and placing it back on our balance, which has already been zeroed to account for the weight of the heat-proof bowl. And now you can see our reading of 0.984 grams. We have had an increase in weight by burning the steel wool. So I want you to try to think about how that might be possible. An increase in weight after we'd built it. It was 0.953 and now it's 0.985 grams.